Good afternoon. This is the third day of Political Science 1001, Power in Politics. It is Friday, the 12th of January, and you are at home, and I am at home because of the weather, but I wanted to make sure that we stay on the syllabus, so I am going to record the lecture with the PowerPoint slides so that you can use those so we can stay up to date, and we will be on track to finish this section, chapter 2 of the book, and this section of the course on Wednesday, the 17th of January, next week. So if you remember from this past Wednesday, our conversation was mostly about scientific reasoning, understanding some of the logics of science and how we know things, how we think about the world around us. So where we're moving today is to talk about that in the context of political science a little bit more specifically. So we're talking about studying politics scientifically today. We'll define scientific research. We'll talk through different types of research and then some of the logics that we use to think about answering questions and to learn about the world around us. So I wanted to kind of keep talking about some of the challenges that we talked about at the end of class on Wednesdays. What are the limits of science? Or in particular, the limits of humans studying science or using the scientific method. And the first thing to think about in this context is that there are quite a few reasoning errors that we are subject to. The first one is overgeneralization. Now, overgeneralization is something that we do a lot of. It's using our personal knowledge to assume generally. This is a particularly important issue in political science because the topic of politics is so widely discussed, and much of the news that we hear or information about the world around us is involved in or talks about politics. And one of the challenging reasoning errors that many political scientists deal with is that we assume that we think about politics the same way that the average person watching the news or reading a news story online does. But we know from political psychology experiments that that's not true. That about 20% of the population are what's called politically sophisticated, and these are people who are both informed about and interested in politics. And there's actually some good evidence that people who are politically sophisticated take in political information and organize and use political information differently than their non-sophisticated counterparts. Now, this is not a value judgment, right? There are plenty of reasons why people may not be interested in or know a lot about politics. Not everybody's goal in life is to be a political junkie, right? But for those of us who spend time thinking about this, for whom it's your major or just that you are interested in politics, you're going to look at things differently. And so why does that matter in terms of thinking about reasoning errors? Well, because that's where overgeneralization comes from. You should never assume that you think about politics, that you think about issues or problems or candidates or campaigns like the average person does. Because just by being in a class about politics, you have entered the political sophistication realm. So I remember as a graduate student, it was one of the first classes that I took was about public opinion. And I remember thinking as we were having all these conversations about how public opinion is created and how people think about politics, I remember sitting there thinking, that's not how I think about politics. That's not how my opinions were formed. This can't be right. And it was when finally the professor introduced this idea of political sophistication and the difference it makes in political reasoning that all the lights went on, and I said, oh, that's what's happening. I can't assume that everybody thinks about politics the same way I do. And so that's one of the reasoning errors that we have to be particularly careful of when we talk about politics in the context of doing social science. The next reasoning error that we need to pay attention to is what's called selective observation, which means we choose observations because they fit our assumptions. Now, to some degree, this is inevitable for us in doing social science in general. Why? Because I don't care about studying all those countries in which there never has been a civil war. I care about what causes civil wars. But there is definitely some challenge in just looking at countries that have had civil wars. Why? because they will not show us all of the characteristics that help prevent war or stop war. And that's what it means by selective observation. So some of it is like based on the idea that, oh, well, I want to understand how people think about politics, so I'll ask just my 5 friends. Well, your 5 friends may not be, maybe systematically different than the people at large. So sometimes it's just that, which sort of ends up being intellectual laziness. But lots of times it's about the phenomena themselves, right? One of the reasons that we have so much more systematic knowledge and understanding of things like how Congress makes decisions or how a bill gets passed is because we have so many members of Congress over such a long period of time. We've only had 45 presidents, right? So we actually have a much smaller group of observations from which to talk about when we think about presidential behavior. Now, we can expand that and say, well, maybe we should think about that in terms of democratically elected leader behavior, and then we can get a larger group of cases to look at. But this is one of the challenges that we have to deal with in social science, both in terms of being intellectually engaged with our project, but also recognizing that there, to some degree, that the things that we study may automatically create selective observations. The third reasoning error is just inaccuracy, right? Inaccurate observations, not even intentional, right? Like I have gone through data sets that I've been using and found errors that are just because somebody hit the wrong key on the computer. So that's another thing we have to pay attention to or be sure that we are not doing, which is why people double check results. And then finally, illogical reasoning. Now, we talked before about the idea of not necessarily completely relying on logic, but there are some really important ways that we use evidence to create explanations of the world around us, and we have to be sure that those things are logical as well. It's pretty easy to make a jump to say, well, every time it snows, the ground becomes white. And that's true, but the ground isn't becoming white. There's white stuff landing on the ground. So that's one of the things we need to pay attention to is what is the mechanism? What is the reasoning behind saying that A causes B causes C? Okay, so that gives us kind of an understanding of how we use information, how we think about information, some reasoning errors that we might have. But how do we use this information that we've gathered, this data that we've gathered, in a way that helps us understand more about politics? Well, there's sort of 2 ways of doing this in social science, and it's a pretty stark gap between the two, particularly in political science. The first thing is what we call normative analysis. Now, normative analysis is about understanding how we should do things. So this is about sort of guiding principles of the world around us. And in particular, also asking big questions. These are should questions. And we do have a part of political science, of social science, that does that. For poli-sci, it's called political philosophy, and we require you to take at least a course in political philosophy. Actually, I think it's 2 as a major. And what political philosophers do are to think through how the world ought to work. So thinking through how should we think about democracy? What are the characteristics that a country absolutely has to have in order for a democracy to work well? How do we judge what a working democracy is? What do citizens need to have in order to be good citizens within their system? That's political philosophy. That's big questions, it's guiding principles, and it's a part of political science. But it's not a big part of political science, or it's not necessarily a part of the kind of political science that we're going to be talking about for the rest of this semester. What we're really talking about in Power and Politics is what we call empirical analysis. And to a great degree, there's not a whole lot of overlap between normative and empirical analysis in the whole discipline of political science. There are some people that are trying to bridge that gap, and particularly in the examples that I used in things like talking about democracy, there have been more kind of questions to say, okay, well, if we believe that a country should be this way in order to be a functioning democracy, how might we measure those things appropriately? But you're not generally going to see things like, Marxism or John Locke's philosophy being tested empirically. Those two things don't necessarily overlap. Much of what political science is empirical analysis. And empirical analysis is the how and what. It is the describing, it is the analysis of political reality. It's the gathering of data, right? So in normative analysis, you're thinking through logically how things ought to be. In empirical analysis, you're thinking about what is and how do we best measure what currently is the case. So we split this into two kinds of empirical analysis. The first is what we call quantitative analysis. And quantitative analysis is the stuff that you can count. So we can tell you how many people voted for a particular congressional candidate in a particular district in a particular year. That's quantitative. It's numbers. Or what is the average income of people who voted for that person, right? Those are our quantitative kinds of analysis. And we do actually work to figure out good ways to do quantitative analysis when we're trying to count things, because quantitative analysis is the easiest to use statistics with. Right, so provided the data is as accurately described, we can use statistical techniques to figure out answers, to understand what are the interrelationships between one situation and one actor. Right, so even things like survey questions, we try to move into quantitative realm so that we can use that and use statistics on it. The other kind of empirical analysis is what's called qualitative analysis. And qualitative analysis is not about things you can count. It's about ideas and concepts. So one of the things that we're going to do later in the semester is we're going to learn about different kinds of data collection techniques based on either quantitative or qualitative analysis. So in quantitative analysis, we're going to figure out how to count things, right? That's what survey research is, and sampling and figuring out information from existing data like census data. But qualitative research techniques for getting at qualitative analysis are things like doing interviews and doing focus groups and seeing how people talk about ideas. And those are just as important because there are lots of things in politics that we can't count. How do you put a number on whether a person believes that we ought to have the death penalty in the United States or not? You can't. There's no way to count that. But it is still a real thing. It's still tangible. It's still something that we can measure and use as a piece of analysis. And so that's why it's qualitative research. Both quantitative and qualitative research are scientific. It tends to be that people tend to look at quantitative research as more scientific sometimes, particularly in the context of the things that we talked about earlier this week when we talked about hard science versus social science. But the reality is, because we know from our conversations on Wednesday that science is a process, not an outcome, or not the data we're collecting, we can do qualitative research scientifically as well. So they both fall under this definition of scientific research, which is a self-correcting, continuously developing way of knowing, a method of testing theories and hypotheses by applying certain rules of analysis to the observation and interpretation of reality under strictly delineated circumstances. And honestly, I could just shut everything down and go home now, because this is the entire semester in a nutshell. But of course, we have to talk about, and we'll talk about over the next couple days, next couple class meetings, what's a theory? How do you make theories? What's a hypothesis? How do you get a hypothesis from a theory? How do you test a hypothesis? How do you know if you're right or wrong? How do you interpret reality in ways that help you understand whether your hypothesis is right or wrong? That's basically what we're going to be doing throughout the rest of the semester. But the important thing to take away from this conversation right now is that both qualitative and quantitative research are empirical, scientific forms of gathering data. And we're going to talk about them in those ways, and we're going to compare and contrast what is the best kind of data to measure with those methods, but also how is the best way to make conclusions or to draw conclusions from the data that we gather in those two different kinds of scientific research. So that's a lovely definition of scientific research, but what does that mean practically? Well, let's go through a list in terms of understanding how we describe scientific research, or what are the characteristics of research that is scientific. Well, first, it's explicit, meaning that it's transparent. All of its assumptions, all of the things that it is trying to measure, what constitutes a measure and a category, all of those things are put forward first if we're saying that this scientific research is explicit. Now, that doesn't mean that there aren't times when you do experiments and you don't tell the person who you're experimenting on exactly what you're trying to figure out. That's a different question, and we'll talk about that both next week when we talk about ethics and when we start talking about experimental method a little bit later in the semester. But the goal of scientific research, remember, is information, conclusions that are communicable. And so in that sense, scientific research is explicit. When you are reporting on your research, you're telling the people who you are reading about your research all the important details about it so that they can judge it for themselves, whether it is in fact making an accurate description of the world or coming to an accurate conclusion. So explicit is first. Then it's systematic. Systematic means that you do it the same way every time, that you are using a process of inquiry, that you are looking into these questions or these issues in the same ways. So, for example, one of the things that you have to think about, here's a good way to think about it. If I'm speeding, what does speeding mean? In everyday life, it doesn't matter whether I'm going 5 miles over the speed limit in my car or 10 miles or 15 miles over. But if we're doing scientific research about the impact of speeding, then we have to know exactly what we mean by speeding and use that definition every time. So that's part of being explicit, but it's also part of being systematic. And so if we're looking at a research project that says, well, how many more traffic deaths happen when people speed? Well, we will know that a certain number of traffic deaths happen when people on average speed 10 miles over the speed limit, and a certain number happen when 15 miles over. That's what is required by this idea of systematicness. We need to use the same definitions over and over again because then they are comparable. It needs to be controlled. The controlled idea here is it's actually kind of a challenge for social science in many ways. But the expectation for control is that you can rule out other possible explanations. That's the goal of control. So if you're doing a research project and you've explicitly laid out the things that you need to know and how the assumptions that you're making, you've systematically laid out what the measures are that you're using in order to gain this data, you have to be sure, using our speeding example from before, that those traffic deaths aren't being caused by something other than speeding, right? So there are various ways we do this. Like in quantitative research, we generally use statistics to do controls, which we'll talk about later in the semester. Experimentally, by doing controls, what you're doing is you're testing something on a group of people, and you're also using another group of people who don't have anything done to them to see if their responses are similar. Because you want to make sure that what you are positing as the reason something is happening is actually true. Because we can think of a whole lot of other reasons why there might be traffic deaths, right? People may be drunk driving. There may be bad weather like there is today, right? There are all these other reasons why. So we have to make sure that we're comparing apples to apples, that we're just comparing speed versus speed as opposed to speed plus weather or speed plus alcohol. That's what control means. And it has to be transmissible. This is the same thing we talked about earlier this week, that you have to be able to communicate science and the information that you gain. Now, one of the questions that will come up and comes up a lot in the sort of popular conversations about social science is whether scientific research has to be predictive. Because that's one of the characteristics in particular of hard science, is that if you are doing an experiment, the same experiment over and over again, if you're taking two chemicals and putting them together over and over again, you should get exactly the same result. It's predictive. It says that anytime I put these two chemicals together, I will get this result. Social science doesn't do that very well. Why? Because we don't do control very well. And that's really the bottom line, is that we have trouble being predictive in a lot of cases because humans are humans, and they are going to do complex things that don't necessarily fit into our schemes of being able to do scientific research. This is why, generally speaking, when we talk about social science, and you'll hear this term again and again throughout the semester, we're doing what's called probabilistic science, meaning that we can predict what will happen within some margin of error. Right? In fact, we will spend a lot of time talking about margins of error and what that measurement means and how it looks. If we know that something will happen over and over again, that's more along the lines of deterministic science. Right? So when you put a certain number of molecules of sodium and a certain number of molecules of chlorine together, you will always get table salt. But that's not how social science works, because we can never... No two people are exactly the same, and so how they will respond to things, how things will be different, means that we can be somewhat predictive, but not fully predictive, and that will be something that will come up again and again. So let's talk about the types of research that are done in political science and in other forms of social science, but this is more directly linked to political science. First of all, we have something called exploratory research. And this is the kind of thing that you do when you're saying, I have a question. I wonder why something works that way. And you have not necessarily come up with a systematic way of studying or gathering data, but you're trying to figure out if there's something interesting going on. And so this is about satisfying curiosity. Many times at the dinner table in my house, somebody has to look something up on Google because we want to understand something better, like why people can't breathe underwater and all sorts of things like that. That's exploratory research at a certain level, right? We're satisfying curiosity. You also use exploratory research to test feasibility, to find out how much it will cost to get to an answer, to understand what you would actually need to do, right? So this is what comes up when you think about things like pilot studies or just trying out a new technique to see what you would need to know. And then you also do things to develop methods. You do exploratory research to decide, to figure out, well, does a certain kind of question in a survey about a family's income, does that do a better job at getting people to be comfortable telling people what their income is or not? Because that's, for example, that's one of the problems that we have in survey research, is it's generally pretty difficult to get people to tell us how much money their family makes. But it's actually really, really important to understand social and political behavior. And so you might do exploratory research to figure out what's the best way to ask this question. And then also other ways to refine questions and hypotheses. Now that's going to make more sense in a minute or two when we talk through the logics of research. But what the reality of research frequently is trying something, realizing it doesn't work, and starting over again at the beginning. All of the published research that you may find if you go looking for it in the library in social science or in hard sciences or in any of the other sort of what we think of as academic journals is not going to be a project that started with something and ended at exactly the point the researcher thought it was going to. It usually is the product of other kinds of exploratory research that happened first to help them refine questions and hypotheses. Then we have what's called descriptive research. Descriptive research tends to be one of the early phases of good research. It's particularly important in areas that we don't know much about, because descriptive research is about accurate observation and demographics. So, for example, if we go back to our earlier conversation about democracy, we can't study democracy in different countries and other parts of the world unless we understand the different cultures and context of those countries, right? So we need to have descriptive information about how democracy works in Thailand versus Nicaragua, right? We need to understand what the differences are. And so that's why we think about descriptive information as accurate observation and the demographics of the people involved. Now, there's a lively debate in political science as a discipline about the worth of descriptive research in political science, mostly because there are lots of other social science disciplines that are good at collecting descriptive data. So anthropology is particularly good, sociology to a certain degree, and then of course history in its context is a social science, gathering this kind of information. And so, but for our purposes in understanding what good research is, you have to know what you're talking about. There must be some form of descriptive research first, whether you do that research or you rely on other people's descriptive research. And then we move on to sort of what's the gold standard of research in social science and in scientific endeavor, and that's explanatory research. This is research that has valid and reliable observations, right, that goes through that whole list that is explicit, systematic, controlled and transmissible, right? So you have this valid and reliable observations that have satisfied all of those characteristics. And it can be the basis for valid causal inference. Now that's kind of a big phrase, and I'm not expecting you to fully grasp what that means today, but it's something that we'll come back to again and again throughout the semester. The goal is to take the information that we have to help us know about the whole world around us. And that's what causal inference is. It's being able to say that, you know what, generally speaking, how much money a person's family makes has a big influence, has a direct cause on what party they vote for. That's causal inference. And it's only valid causal inference if we've got good data and explanatory research to back that up. That's really our goal. And that's what we're going to spend much of the semester learning how to do. So don't worry if right now you're thinking to yourself, oh my gosh, there's all these terms and these ideas and how do these all fit together? Today, in many ways, is an overview of all of the things we're going to be doing through the semester. But this gives you kind of the 10,000 foot level, and we'll dig down deeper as we go. So to do that effectively, we want to talk a bit about what's called the logics of inquiry. Now, this may be something that you will have seen before in other contexts because it's a pretty standard way of describing how we think about the world and how we come to conclusions about the world around us. The important part of this for us in Power and Politics in this course is because this will help us understand the relationship between the data we collect through these methods that we're learning and how we take that data and use it to prove a point, to come to a conclusion, to explain something. So there's two basic ways of thinking about the world. And this is induction reasoning or inductive reasoning and deduction or deductive reasoning. Now I'm going to skip ahead a couple slides. And we're going to start with deductive. Now deductive logic of inquiry is something that you will have come across when you think about or hear about, even in popular culture, many of the classical philosophers. So the Descartes' notion of I think, therefore I am, that's purely deductive. Why? Because what he's saying is I have this theory about what makes me human. It is thinking, right? And because I can think, therefore I am human. That's deduction, right? So the other kinds of ways we can think about this in terms of politics would be to say, I have a theory, I want to test it. That's deductive reasoning. So let's say the theory is that, one of the most obvious ones and ones that can be a really good example for us this semester is there is a existing theory that says democracies don't go to war with one another. Okay, so if we're using the deductive logic of inquiry, we're starting with that theory. Now, what a hypothesis does is it gives us a way to test the theory. It says, all right, if this is the theory, what would I need to know to determine if that's true or not? So our hypothesis in this case would be something along the lines of, in any given year, no two democratic countries will be at war with one another, right? Because what are we doing? We're making the theory testable. We're breaking it down. We're making it explicit and systematic. We're saying, okay, so we're going to measure it by year and 2 democratic countries. And of course, you're going to have a definition of democracy, because that's another part of this. And then the idea is you go and you collect data, and you use that data to say, all right, is this theory true or not? So the process moves from theory to hypothesis to data, and it reflects a top-down approach from the abstract to the concrete. You're taking a theory and you're saying, all right, what data would I need to figure out if this theory is true? And then this is a definition actually from your book that I really like. A hypothesis is an expected relationship between phenomena derived from a theory and tested with data. Okay. Again, don't worry if you feel like this is too much too fast, because we're going to spend a whole lot of time talking through these things through the next couple of weeks. But that's not necessarily how all research goes. Like, this is the classical model. This is what we expect when we talk about research. But this is not necessarily what's always going on. Lots of times we're doing induction, which is an inductive logic of inquiry. And notice here that the triangle is the same as the deductive, but the arrow is going a different way. This is where we start with data, and we say, we observe all this stuff happening, we find the empirical patterns in that, and then we create a theory. So how did we get to that theory that democracies don't fight each other? Well, it started out as somebody sort of looking around and saying, hey, there's all these wars all over the place. But you know what I'm noticing? It doesn't look like democracies are fighting. I wonder if there's a reason for that. And so they went and they collected data. They went and they collected the same kind of data. So defining what a democracy is, and the relationships between 2 democracies. And then by each year, you say, are they fighting? Are they not fighting? So you're collecting that empirical pattern, and you're saying, look, democracies seem to not go to war with each other. So instead of coming up with a theory first, you are gathering data first and letting that data give you a theory, or bring you to a theory about what is happening in the world. Now, this is lovely. Both of these models are lovely. The process here moves from data to empirical pattern to theory, reflects a bottom-up approach from the concrete to the abstract, and mirroring the earlier slide, an empirical pattern is a relationship between phenomena inferred from data. But here's the reality. Most of the time, we're doing it all together. And I don't mean that it's all scrunched up in a ball together. I mean that we're doing these processes over and over, and they're related to one another. So if we look at the hourglass on the left side of the screen, we may start with the theory and come up with a hypothesis and collect some data. But that data may not confirm the theory. It may actually show us new empirical patterns, and then we have to come up with a new theory. And the same thing works on the other side, right? We may have this data and we're like, what's happening here? And we come up with empirical patterns and we create a theory, and then we test that theory with a new hypothesis and new data. This actually has a name, and it's what we primarily do. It's called retroduction. So you can think of it almost as a circle, or in that up and down versions of the triangles that your book figures use. You're doing both induction and deduction. And that's really what good research does. And part of the important piece of this that helps us understand this better is to recognize the fact that when we do these processes, we're generally not doing them alone. It's very rare that there's a topic of study that only one person is studying. And so there are groups of people, and I'm not even talking like a group of scientists who sit down in a room together and do this. I'm talking about people studying the same topic in different parts of the country or different parts of the world, whose conversation together produces this retroduction kind of logic of inquiry. The important things when we talk about retroduction are things like concepts. Remember the communicableness, and that we have to be explicit and systematic. We generally come up with specific concepts that help us to define the relationships that we're talking about in a hypothesis or in an empirical generality that we're finding. And we also have to be careful and make sure that we are being clear in our assumptions. Right, so let's go back to our retroduction screen here. And using our ideas of testing whether democracies fight each other is a really good question here, or is a really good example of the need for concepts and assumptions. We have to define not only what does a democracy mean, right? So what is, if we say a democracy is free elections and freedom of the press, well, how free? How many parties does that have to be? What kind of choices? How many people have to be allowed to vote for it to be a democracy, right? So is the United States before the Civil War a democracy when only white males could vote? Maybe, maybe not. It depends on how we actually define the term democracy. That's why concepts and assumptions are important. The same thing is true about going to war. What is a war? Is it a declared war between states, or is it hostilities between factions inside the states, right? Are we in fact at war with a terrorist group? Is that possible to be at war with a terrorist group or not? That's about definitions and assumptions. That's about concepts. And so that's why this process is so important, or understanding kind of the broad outlines of this process is so important. Because what we're going to start moving toward next is thinking about, all right, how do we come up with theories? How do we gather data to test them? And we're always going to be referring to these logics of inquiry because they're kind of the framework on which we put these concepts of making arguments, of coming up with conclusions, of collecting data. So that's it for today. We will finish Chapter 2 on Wednesday, the 17th, which is the next time that I will see you. If you have any questions, please go ahead and send me an email, and I hope you guys stay safe and stay warm today. Thanks.